instead of writing these queries as text strings, which of course is really error prone, I wanted to use Scala and the type system of Scala. So I basically needed to write something like that, which is what the Atomic expects, which is like a query language called datalog, which is like a mathematically described language of logic, where you have like different where clauses. And you have find and where and inputs and a little bit more, but this is basically, so this is a text string. So I don't want to write this text string in Scala, I want to write this instead. I want to write as little as possible. So what's the minimum of this? I think that's the person.name.h, because you have all the information here. You have name there, age there. You have a lot of redundant information in the query. That's all right here. And you would even have the types of the name and the age, because your name is a string and age is an integer or how you define it. So you have all the information needed. So in Scala you would call it peer, which is just a library that you import into your application process. So you basically just call the query function of peer and give it a string, which is what you just saw. And then you create a connection to the database and give it a database value. So what the Atomic peer is doing, it is using the database value that you give it from the connection and apply this query to it, and then you get some result. But I want to write this. I just want to write person name age get. That's the minimum I want to write. So there's just this little problem, and that is that when you do this call to the Atomic peer, you get back like a very untyped result, because you get a Java collection of list of objects. So there's no type. So you don't know what type you get back. I want a sequence of tuples of strings, and so I know what I get, so I can continue working on that. So if you do it manually, you would probably do something like this: convert it to Scala and make a sequence, map over it, take each sub item, convert it to Scala and match it so you get a name and age, and then cast it to the right types, and then you get a sequence of string and age. But it's quite tedious to do this. So we want to do it with the macro instead. So we have two aspects here, because we have what we know at the compile time. Then we could create an object which is like a person.name.age, and we could call some function, a macro function of that. So we would get some kind of a molecule class that we have a get function on that we can run at runtime, right? So we want a macro to create this that has a get method. Yeah, that's what. So the molecule here is we could create some new anonymous class called, or instantiate a molecule class that has a get method that does all this. But how are we going to get this? We want to let a macro do that. So a macro should create all this for us. So when you have, I don't know how many of you have worked with macros in Scala. Yeah. So there's something called quasi-code quotes, which is when you write the queue and then the quotes, then you can write Scala code within there, which is what the macro is going to create then. So you can basically just put in some Scala code within the text string. So and here I took the code we saw before, the macro 2, and make it a get method. But I haven't made the query yet. So, but I've done all the casting to the first type and the second type. So the implementation of a macro would be like some method a little bit simplified here, that takes some DSL, which was this person.name.h, and then creates a molecule tool for us. So when you have the dollar sign inside this quasi-clause, it's like a reference to a variable outside. So we need to implement that first. So you see the person name h, we could let that extend some boilerplate code that tells us that this macro will receive something that is a subtype of M2 with the first type and the second type. And in our example, it would be like a string and an integer, for instance. So this is what we want to give it to the macro. So that's the implementation. And then we have the interface, and we can define it as an implicit definition, which in Scala lets you write this without the M. Call it so. The Scala compiler just realized when we write this that there's a get method here, but we don't have any object here. It should, but we have a macro here that can create one that gives us a get method here. So that's the implicit part of it. So that makes it so we can write that write like this. So the compiler does the work for us here. So when you want to implement the query, then we do some funky stuff here, because we make a pattern matching on the code we get in from the DSL. So this is the DSL code that we get into the macro. So that's a tree. So this DSL come in here, and we take that DSL and match it. So we look for patterns where we have some code, and then a dot, and then some code. And that matches this because we have some code here, person name, that's the previous, and then the attribute is h. So we can, from this h, we know it's called h, but it also has a type because this has a type. So that type, we can then extract, it comes from basically a person class. So we know that the namespace of the attribute is person, and then the name itself, h, is there. And the type, we also have it implied in the code for this. So we know it's of type integer, so we get that here. And then we also know that it's cardinality 1. So we create a little model of that attribute with the information that we need to create the query there. And then, I just want to say that. So when we have done this, then we traverse the previous part, which is from here to here, right? So then we take that, then that comes in because we call traverse again. So now this is the tree that we get in here, right? So now it's a name here, and then just the namespace here. And then when we do it the last time, it will only be the namespace. So that's the way we go backwards in the molecule to take one part at a time, and then we can build out the model. So, and then we can build the query string from that model there, the sequence of those. So it's basically that. So, as you see, the namespace here is we have a class. We want to have a class so we can write this in our code. We want to be able to write person, so that has to be a class somewhere. So that's what I call the molecule DSL. That makes it possible for us to write person. And then name. So that's the first attribute. So that gives us person string. So when we want person name, then we get down to this person here. The type is here. And this one we haven't implemented because we only need it to pass on the information that it's a string. So the name is a string, right? And when we get to the next one, we get to the h, and that's an integer. So we go from here to here, that's the person 1, goes down here, and then to the h. You get that? So the first we collect the string type here, that is the a here, and then when we say h, we get person 2 here, which has 2 types, right? So the first is string from that one, and b is the integer from here. So that's how we build up the information about what types each attribute has. And lastly, we have the get method, which is what happens at runtime. So that's the method that we want to call it runtime. So the macro has to implement that method, and that was the get method that we saw before. That's what we need. So that's that method there. Remember that. That's what we want to have implemented here. So this M2 here has to have this get method. So all this is a kind of a boilerplate code. You don't want to write this manually, because you have all the errors. If you have like a molecule which is like 10 attributes long, you would have to have like 10 classes with more and more types arguments. So you want this created for you. So of course you have an SPT plugin. We created one which is translating what we define in a schema definition file. So here I define something that can get translated to all this, so I don't have to write all this by hand. So I just write as little as possible to make that happen. So I have, for instance, a trait called person. So it's here. So that person is, when the plugin looks at this file here, it takes it line by line and say, okay, now we have a trait person here. Then we need to have like all these classes here. And we need also to have the age and so on. So it goes through and it also needs to know that, well, I defined it as one integer, so it's the age type argument is integer. So this is the minimum of information I need to define my schema. You see? So, and then what can I choose from here? Then I have another DSL. So I know that I can choose one int or one string. So I have different combinations of cardinality types. So one string, many string, one int. So those are the two I used. And then you have like one, and then you could have a reference to another namespace. That's how you do the references, right? Or have many invoice lines and so on. So you would have one trait which was, you have another trait citing address, for instance, and then you can make a reference from there down to the address, right?
Question, so in this case, age is an attribute of person, it's not really like name.age, it's not an attribute of name?
No, I'll come into that because you're totally right, because it's, the person is just a prefix to the attribute name. And then you have person/name and person/age, right? So the person here is reused for both of them. So type-wise, it's just there to make it able for us to write it like this. Yeah, and then you have some different options. So you can decide that it has this full check, so that it's a component with like these recursive retractions and stuff. So it's a very easy way to define it. So basically, the whole ecosystem of molecule is that you have a schema definition DSL that makes it possible for you to define your schema. So and then SPT compile it once when you compile your project to some molecule DSL or boilerplate code. That makes it possible for you to write molecules that then gets compiled to datomic DSL, like queries, and then you run those. So this is the ecosystem. So this is where you would be most of the time, because you would normally have defined your schema, and then you would start doing a lot of queries on and on and on. And then sometimes you would add an attribute or change the schema a little bit, or do a migration or stuff like that. And then you just recompile the project, and then you continue making queries over and over again. So I have a DSL to create a DSL to create a DSL. That must be a meta-DSL, right? So this is basically the ecosystem of molecule. Do you have some questions for that?
would be, I guess it's hard for you to show now, but it would be interesting to see a few kind of simple implementations. Like you were showing person.name.age, for example. That's one simple query that you would write in your code, in your Scala code. And you would get the name and the age, and it's type safe and all that. But I guess there are other kind of combinations you can write.
But I'll show you a lot of examples of those.
Or also, inserts or stuff like that. They create new data. And
but I'll come to that.
okay, good.
I have a question about when you have relations. Then you model that as many, or if you have, what about like n+1 loading of the data when you do queries and you have a relationship to another data type, and you will get many of those. So you would have like lazy loading, or you would have to load everything at once, or
it's actually loaded all. Everything is loaded.
So if it's large, if the relationship is large, it would be actually bad performance.
I'm not sure about it. It's a question I had myself, because if you have like 10 million records, I've seen presentations where they get like 10 million records just like that. Because
I mean, if you look at like Hibernate or something like these types of object mapping, it's the same kind of problem, and it's kind of the hard part of doing object relation mapping. But
how shall I say it? They have these different indexes, which of course speeds up things, and then they can take segments of the whole data sets. But I don't know actually if you ask for, you can't ask for the whole database. Then you get an exception. But you can, if you get I don't know, 100 million records, I don't know what's happened, because if it can't be in memory, I don't know really what's going to happen. So I can't really answer the question.
Is there a count option, like in SQL you would maybe select count to see how much you would get?
There are different aggregate functions. So you could count how many facts you have in advance. And you can also narrow it down to a subset, so you don't get all persons. It's seldom that you would be interested in all persons. You would probably be more interested in how many persons do you have. Or a subset of the persons. Give me all persons who are customers, or who are this, or whatever, right? So I'll come into those with the expressions that narrow it down.
The first DSL, is it something else than just defining traits? When you
you mean this one?
Yeah, I guess.
This is one. This is just one to say what types can I define in my schema. So it's a very little DSL is like this long. So it's like maybe 50 lines or something. So it's just so that the SVT plugin knows that when it sees one string, it knows what to do. Then it knows that it can do this. So it's basically just to make sure that SVT doesn't fuck up and knows exactly what to produce. So it's a closed ecosystem, because you can only define the things I've defined here, which is basically all the features of Datomic. So when you use this, then you're sure that the SVT plugin can create this, because otherwise it will give you an exception here. So in that way, it's a safe system, because everything is defined from start to end.